All right, we are on case 2 for section 10.5 partial fraction decomposition. In this case, the denominator has a repeated linear factor. So you can have something like x minus 1 squared, or even x to the third, for instance. And the reason is that you have x to the third, that is still the same as x minus 0 to the third. So it's still that repeated linear factor. All right, so when we have that repeated linear factor, the form that we're going to express this in is going to be a sub 1 divided by x minus a plus a sub 2 divided by x minus a all squared plus dot 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 plus a sub n divided by x minus a to the n. So you can see that you're going to have as many terms as your exponent is. So if our exponent was 3, you would have a sub 1 over x minus a plus a sub 2 over x minus a squared plus a sub 3 over x minus a cubed. And so just to note that when you have just an x, it still counts as a repeated linear factor. All right, so for this problem below, we're going to want to set this up as a over x minus 1 plus b over x minus 1 squared. And then now we have another factor. It's not the same, so we just think about it as case 1, and this would be c over x plus 1. And in order to solve for a, b, and c, we want to make the denominators the same. And so what we can do is multiply by what is missing. So in this first term, it's missing an x minus 1 squared and x plus 1. So I'll multiply the top and bottom by x minus 1 and x plus 1. The second term is missing x plus 1, and the last term is missing x minus 1 squared. All right, now that all the denominators are the same, we can go ahead and multiply everything on top and just be dealing with the numerator. I am going to write my left side as x squared plus 0x plus 0. And when we go ahead and multiply this, we'll end up with x squared minus 1 and then times that a. So it'll be ax squared minus a plus bx plus b. And then when we multiply out x minus 1 quantity squared, it's going to give us x squared minus 2x plus 1 and then distribute c. So we'll have cx squared minus 2cx plus c. So from here, what we're saying is that the equation on the left is the exact same equation on the right. And so in order to solve for our parameters, we want to put the x squareds together, the x's together, and the constants together. This will leave me with a plus c times x squared and plus b minus 2c times x. Lastly, it looks like we're going to have, let's just write this as b minus a plus c. I'm having trouble deleting. So negative a plus b plus c are the constants. All right, and okay, so now we have everything matched up, right? X squared, x, and constant. So what we're going to do is equate the coefficients. In order for this left side to equal this right side, a plus c has to equal 1. And 0 has to equal b minus 2c. And 0 has to equal our, and I'll just rewrite it as the negative a plus b plus c. So now we have, from all this, we have a system of linear equations, and we want to go ahead and solve this. And we'll do that in the next part.